Thank you, Asha, for a very generous introduction, and good morning to everyone. Asha has given a quick intro of me, but I would call myself as an AI convert. Can you hear me over there? It's a little bit of a glare. Okay. My own story with AI has been more of a love-hate love story. So I'm going to take some time today to go through some of my own experiences, give my insights and what I've learned through in my career around the evolution of AI. Also will bring up some of the interesting examples where we at Intel have been working on, specifically from India. And then I'll introduce my co-speaker here, and we'll have some good information from him on what Gnani is doing along with Intel in this particular area, right? So if I just look back, and I was just thinking about it as I came into this conference today, how many of you have been in the industry for 10 plus years? Anyone around? Okay, a few hands raising up, right? I'm sure some of these would, you would resonate with this. When I was graduating out of my college, artificial neural networks used to be in research realm. Typically, we had a 300 credit course, which some of us bravely took and sort of, thank you, and scraped through the term. And then, most of us used to see speech recognition and video, any action recognition, and those are problems which are now, as we call AI complete problems. They are very hard problems to solve. We always used to wring our hands around saying there's no way speaker recognition is going to be deployed anytime in the near future. And I still recall submitting simple knowledge system inferences and waiting for 2 days for some pathetic result. And when I look back, that's what we call early 90s as a, it was supposed to be a winter of AI. We were just coming out of those winters. And now here we are in a sunny summer, enjoying the weather, and you can see the effect and the deployment and the scale that's happening in this machine learning domain. And I hope this weather stays through. Okay, so let me start at just taking you back a bit to look at and appreciate where we are at this point in cognitive systems. If you look at a brief history of mankind, and this is not something purely technology, but marrying a little bit of economics and psychology that came as mankind evolved, right? We are not strangers to inventions or technologies. If you have read any articles from Richard Lipsey, a very celebrated Canadian economist, he talks about something called general purpose technologies, technologies that spurred societal progress and evolution through the ages, right from fire all the way down to the wheel, the metal, the sailing ships that led into New World explorations. If you can see that post-Renaissance era, there's been an explosion of technologies as we know today. What did this help? And if you look at the human values that we mastered, conquered, and we are approaching through the ages, we started with subsistence values as we used the technologies for, whether it's survival, whether it's safety, whether it's security. Then we moved on to power, acquiring order, prosperity, and hopefully we are in a place where we have mastered the basic needs and moving towards community, peace, and harmony. This is a psychologist's view of how mankind evolved. So I ask the simple question: are we now at I would say one of the most transformative periods in history, especially with the advent of cognitive systems that's coming in, right? And the deployment of it. So maybe let's think through this as we go through the talk, and then we can have a discussion about this. So again, going back, right, and if you have gone through courses and used control theory in your previous careers and evolved through it, you'd appreciate this fact that AI is now opening up new frontiers in learning. Most of AI had roots in control theory back then when we started off with analytical models. So typically analytical models for most of you are, who have looked through these courses are models where we represent a mathematical representation of an output input, right? We've had a bunch of these which are more inside out, and we always looked at a problem or a scenario or an entity as an analytical model. Now come in the last 1 decade, where we've been successful is starting to look at world outside in, understanding the world based on the data that a particular problem or a particular entity generates, right? Now, how did this happen? I would attribute this to 3 factors. Number 1 is compute. Thanks to the Moore's law, and we at Intel swear by it, you can see that the compute got miniaturized several times over the last few decades, and we have loads and loads of compute today in our lab, making us much more easier for us to run complex computations which were never earlier possible. And add to that the memory, the dense and more affordable memories that are coming in, right? The next one is data. The digitization that happened in the last 2 decades and the number of sensors that we have deployed all around the place, it's actually ubiquitous data generation that we're doing all around, and we have huge amount of data. I'll double click that a little bit for your information in the next slide. So that helped us to collect a lot of data to gain insights from, which was not available earlier. So that's the second one. The third one is innovation. Some that Sandeep already touched upon is when we were working earlier, previously it was almost a decade ago, it was very few models that we've had with respect to computing, almost no frameworks that were available to the general developers as far as AI is concerned. There were very little primitive knowledge-based systems or expert systems available. We've, from there on, entered the world of CNNs and RNNs and transfer learning and multiple other innovations that are coming up. We've democratized AI so that you can actually deploy this to scale. So these are the 3 factors I believe have changed our world from being an analytically modeled world to a data-driven world. So more on the data, right? I'm not sure how many of you appreciate this, but we are really living in a world of data deluge. The car that I have in our lab today, which I run regularly, collects data it's only a camera data, and I toned down my image resolution just to make it compatible, but I collect data at the rate of about 1.5 terabytes for every 15 minutes of run. That's huge. And this is only camera data. Now, if you consider LiDAR, IMUs, and multiple others, it just explodes. So if you look at some of the market data that's available, the projection is by 2020, when you have an average internet user himself or herself generates close to 1.5 TB, all the way down to a smart factory, which is a badgeless automation center, can go up to 1 petabyte. So we are looking at exascale dimensions here when it comes to data. All this data actually gives us a big business imperative when it comes to AI and machine learning. And it also gives us a chance to look at a lot of problems and gain insights in a much better way. We know AI is going to touch us in a way that not many technologies have touched us before, right? A bunch of them. Today, Alexas are there in every home, which at least I personally never believed a decade ago. Health, I have a few in my own extended family who are receiving very custom cancer care thanks to AI, which was earlier very brute force. Finance, algorithmic trading, retail, personalized shopping that we could do. Government, I'll click down on this on my next slides, but all around the world, if you see, all the governments are in the race for AI. And our country is not far behind. We have a national AI strategy. It's available online. You could check out on one of Gnani.AI's websites. And Intel had played a big part in scripting this strategy along with the government. There are a huge amount of opportunities available now for the ecosystem and developers with the national AI strategy coming up. And I think it's for us to reap the benefits. Energy, transport, of course, everyone's favorite topic, whether it's autonomous cars, whether it's smart mobility, all using AI. And definitely leaded in India. And several other, areas. Now, Sandeep touched a bit about it, but I want to reiterate here very clearly as to why we believe that AI has come of age, right? After a couple of winters and a few springs, right? 2014 and 15, for some of you who have experienced earlier machine learning, we've had some sample scale benchmarks, a few on ImageNet, a few data sets around, some leaderboards running, and a few researchers coming in and providing data. Not much of programming models that are available, mostly C++ or some proprietary APIs. And then most of our training or ML computations happened in the cloud, typically, right? Hardware architectures underlying were CPUs and GPUs. Now come 2019 or 20, it's been a huge change. You see an at-scale deployment today of multiple AI applications. I'm sure each one of us uses at least 2 to 3 on our daily lives. Either we know it or we don't, right? ML frameworks that made it so much more easy and democratized AI so that it doesn't sit in, like what happened earlier, a specialized classroom or in a research institute, but is available to most developers at a click of an API. Compute ratio. Inference really exploded in the past 5 to 6 years. Now you see multiple edge devices that are driving this deployment, and that is where the focus is also going to shift very soon, right? And hardware architecture. So apart from the CPUs and GPUs, we have a huge number of architectures that are coming up right now, which are very specific DL acceleration. Sandeep just mentioned about the project that he is talking about with Intel FPGAs. FPGAs are one of the biggest DL accelerators today, and neural network processors. So we see a huge explosion in edge AI, and the markets definitely predict close to 190 billion economy coming up very soon, just by 2025. These numbers go all around the place. For example, transport alone, if you see smart transport autonomy, economy goes all the way up to 7 trillion if you look at all the services. So there are a lot more, larger implications of having machine learning at the core. Just wanted to give you a bit of a picture on how analytics is evolving with AI, right? Analytics, for some of you who have already been in this space, very useful for many businesses, whether for their own innovation or to build competitive edge. The operational analytics or the very traditional industry had been always a reactive or a root cause analysis sort of an industry, which always used to, again, build on analytical models and looked at hindsight, typically, of what happened or why it happened. Now with AI, you can see predictive, prescriptive, and cognitive analysis coming up very soon, and many of the enterprises would be using these to make their decisions. And the holy grail, which even is applicable to the rest of AI, would be augmented analytics, where the machine actually uses human intelligence to augment its own decisions. I don't think it's too far. Okay, so we talked about multiple facets of AI. I wanted to bring a few inputs on where today the exciting opportunities for AI exist, just to pick your brains or find out some of these interesting areas, right? Number one is better model building, right? Today, the models that exist do not solve all the problems. There is a gap between the promise and the practice, and also the type of real-world problems that we are solving. Not all models are good enough, right? Now, learning with less data, one of the biggest problems that we need to solve, very soon, in order to bring in AI into many more applications. For example, I know that I can, as a human, transfer some of my earlier knowledge or understanding into a new problem and navigate through it. For example, if I've driven in Banerghatta, I know I can drive, say, in Bellandur, but not so for the car that I am trying to, induce ML knowledge into, right? So how do I make this entity learn from its previous experience with lesser data and detect or extend its knowledge to new scenarios? That's one. Unsupervised learning is definitely going to be a big area where I guess we need to move a lot more faster. Augmenting DNNs today. There are multiple areas where, and specific use cases where DNNs may have to be augmented with analytical models with more memory to make them more efficient and more accurate. So what can we do about it? Learning systems which are much more easy to reason, and continuous learning, especially when you look at safety critical or mission critical AI, making sure that you have continuous learning so that you quickly respond to the situations with a very good QoS is very important. A huge gap right now, and some of the reasons we are seeing mishaps like an accident with an autonomous car, etc. Right. The second one, the big area that I would talk about is pervasive model deployment. This is one area which I think is definitely required so that we push most of these deployments into the use cases which we have not yet touched. Especially the main bottleneck that I see is with respect to sparsification, with respect to pruning. These two are big challenges today, and if we can break these, I'm sure there are a lot more deployments, a lot more use cases that the models can be going in. Self-learning and personalizing at the edge. So with the explosion of edge AI, a lot more self-learning that we can bring into the edge, or a lot more personalization, that would help actually explode a lot more of operations. Compute architecture needs, again, coming from a platform provider like Intel, I would always look at what are the requirements from the platforms that really help to move some of these envelopes with AI. Number one, I'm sure a lot of you guys must have heard about bfloat. A lot of you guys must have heard about reducing arithmetic precision while keeping the accuracy. This is one area which is going to be pretty hot in coming years. Most of the silicon companies would be looking at bringing down the weight precision while still maintaining accuracy. It's a good area to look at. The second one, and very classic one, but it's a big gorilla, is how do you make sure that you feed the compute? The interesting part is that compute is no more a bottleneck for many of AI applications today. It's a memory. So how, if you've ever run or profiled any of your training algorithms or inference algorithms, you would see places where the compute is starving for memory or waiting for memory. It's the latencies. How do you feed the compute? How do you break the memory wall? How do you build in new memory architectures so that the compute units get data when and when they want at the minimum energy that you need, right? That's at the minimum power that they need. So that's a very interesting area. It's a big elephant, really needs to be conquered. Domain-specific architectures, many of us are working on. Intel's pretty big on this. You would have seen already certain early announcements on neuromorphic and other technologies. We've moved from traditional spatial, neuromorphic, and quantum, which are definitely going to push the envelope with respect to performance. Again, for enterprise AI, productivity and scaling the needs, especially with respect to large batch-size deployments. What do we need to conquer the fast deployments today, and how do I handle higher order language constructs? Some interesting problems. Again, a big picture view on where we are heading with respect to AI. Right? I found this, if I need to sum up the insights section, I found this very interesting. The entire evolution of AI is interestingly split into 4 waves. The first wave, was when you had knowledge systems or expert systems like the Mycin. You can Google it and find out about this data, this one, especially in the pharma area, right? Handcrafted systems that we've used. We continue to use until maybe 2014-15, right? Second wave, when we had a good at learning systems that came up. DNNs came in and started deployments. The third wave, which we are going to be entering very soon, is going to be perception, which is going to be almost a solved problem. But what comes next is planning and control when you have decisions or further actions to be taken based on the perception. That would be an interesting area, and this is still not all solved. So there are a huge amount of work going on in the research today. In fact, if you talk to any of the vision guys, they would say that vision is a solved problem for me. Of course, most engineers and developers would not say that because there are a lot of implementation bottlenecks still. But as far as research is concerned, whether it's vision or speech, it's a solved problem today. Where most of AI is going is how to do planning, how to do control, how to do navigation in multiple scenarios. And that's an interesting area that's going to come in the next 1 decade. You would see contextual adaptations. It's going to be, I would say, a hard AI problem. Can I have something really that passes a Turing test? Pure data samples for learning, an interesting problem that we need to solve very soon. The fourth wave that I see is going to be something that has to be truly transformative. Now, we cannot crystal gaze whether it's going to be coming in the next decade or much beyond, but definitely I believe that AGI is going to go up the hype curve very soon. It's already somewhere at the start of the hype curve, where we have a system that is not a specialized system. I can have a system that both cooks for me and talks to me sometime very soon, right? Like a human. So today in the world that we are today, it's more of artificial special intelligence, or some people call it narrow intelligence, towards a world of artificial general intelligence. That, I believe, is the holy grail. Hopefully will come in the next couple of decades. Okay, with this, I'll move into the next part of what I had in mind. This is more about how do we realize the potential of AI as a platform. We have a wealth of research that had been converted into implementation today, a good business that we have today. What are the various ideas and interesting problems that we are trying to solve? And I'm going to bring up a couple of instances that we are talking today from the context of India. You will see more about this in our experience zone right outside. Intel, along with IIIT Hyderabad, has released the world's first public data set of Indian driving conditions. Now, this has been an idea that we've been talking about for a year or more, where we were looking at autonomous driving in India. Of course, it is an AI complete problem if you look at it. And as a business, maybe it will not be coming up very soon into India as an autonomous car, not in the true sense right now. But if you look at this as a problem, if you can solve the problem of navigation in Indian road conditions, it will solve most of the corner cases around the world. Because safety is one of the key tenets when it comes to autonomous driving, right? So the state of art that exists today, whether it's Kitty, whether it's Cityscape, and very recently the Apollo data set, have multiple data. But what if you are data scientists around, what might interest you is that the data diversity that we have in the IDD. So this is a 50,000 frame data set with both instance, semantic segmentation and bounding boxes. This has more classes than the existing state of art. 34 classes, new classes added, specific to Indian scenarios, and the data diversity. So if you plot a similar graph for many of the other data sets which are available from the West that are more public, you find very few classes that are prevalent in number, and many others are exponentially decreasing. So when you train your model on that, you would most probably fail when you have to detect those. So an example that we've shown over here, something that a PSP net that we've trained on, say, a Kitty or Cityscapes, when you infer using this data set, would perform very poorly, right? This data set, we see definitely even the models that are existing today really don't drive accuracy even if you train on this. So this is a big opportunity to push state of art with respect to models using some of these unstructured driving conditions. There's already a good amount of interest all around with a bunch of universities. Some mentioned over here, a big community gathering around this. And any one of you who's interested in using or collaborating with us, there is a community around it. Get in touch with us at the booth outside. We have run a couple of contests here with some of the global teams, both from China and Mapillary, winning them, and a team from IAC too won the challenge. And I'm hoping that in the coming years, when we open up more challenges from Intel, I'd see many more of Indian teams actually participating and winning this challenge. And if not at par, definitely much better than what we see from the global teams. Okay, the next one is an interesting, different problem that we try to solve. This is basically looking at derived data and seeing how we can gain insights from this derived data and where can we use this. An interesting use case. What we did here, we have drive assist systems from Intel and Mobileye, and we use those in some of our vehicles to actually identify certain data points around this nightmare called Outer Ring Road in East Bangalore, right? Some of the interesting problems that we found here is the dynamic change of traffic that's not really available even on Google Maps today, identifies the probability of these gray spots, which are basically probable accident zones, and how it moves from the day, right? So a non-peak hour to a peak hour detail. So some of this that we are working with the government of Karnataka to provide this data to the city planners to decide how they want to move about. Okay. Oh yeah, thank you. I did talk about the work with government, a couple of inputs over there. We've worked with the government and Niti Aayog and TIFR to build this national strategy. And a part of this, definitely this you would find, you can Google for it and find more details. There is a center called ICTAI, or International Center for Transformation AI, specifically looking at a PPP model to solve problems of national scale today. We are very focused on smart mobility in this area. Agriculture is another area that's coming up. I'd be glad to give any further information about this post this talk. Anyone who's interested can definitely come by and talk to us. But we definitely see a lot of push from the government that's coming up, which is promising for the developers in the ecosystem here, because a lot of folks can benefit out of these measures that are coming up from the government. A quick look at what Intel's AI community is doing in India. We have two programs today running, and have been accelerating very well in the past few quarters. One focused on startups and developers, students, the Intel.AI Academy, and the second is about the Intel.AI builders. We've had excellent successes with Intel.AI builders and with Intel.AI Academy in the past few quarters, and you will see an instance being talked about at this keynote itself. Multiple ISVs and SIs in India and a huge number around the world that have been building on Intel platforms. So several names and several verticals who are partnering with us in this particular journey. This brings us to one success story that I'd like to call my co-speaker for Ananth.
Thanks, Prabha. So, am I audible?
Can you hear him? Yeah. So Ananth is one of our partners and he heads Gnani.AI. Maybe Ananth, welcome, and why don't you talk about
Sure.
your company and what you're doing?
Sure, thanks, Prabha. So at Gnani.AI, we build speech recognition, NLP, and the whole conversational assistants for domain-specific use cases in India. So when we started Gnani.AI 2 years around, we fooled around playing with Google API, Microsoft APIs, etc. But when it comes to Indic languages, hardly none of them were there then. Today there's only Google APIs. But again, when you move into a call center channel, everything fails. People claim that, yeah, we solve speech recognition. But move into call center channel and a complex environment as in India, where we talk in 2 languages. One is our native language and Hindi with English, Kannada with English, Tamil with English, whatever it is. So how do you handle the dual mode conversational challenges that come in speech recognition for domain specific? So this is what we started solving at Gnani.AI. We went ahead, took few domains where we could solve speech recognition and NLP and then derive the necessary business outputs. So that is what we do at Gnani.AI.
Thank you. And I know you've been at Intel AI Builders program, and can you share your experience? How did we take you through that, and what has been your insights?
Sure. So key things that we did with Intel AI Builders program is, one, the core centers for us is the call centers. Like how do I answer or how do I derive inferences in real time? So with respect to the amount of compute available, how do I get my speech recognition algorithm to be inferred as early as possible? What is the least time? So what we did is we worked with the Intel team to optimize the entire speech decoder. We did a couple of experiments. One, we used Intel optimized libraries. Then we did the architectural changes with respect to the way the data transfers from your network port to your algorithm for the inference. So with that, we got some pretty big results, I would say. Our engine started to perform 40% more faster than it was. So today we decode around close to 4 streams in real time on a single core of Xenon processor. So a 10 core, we could do 40 streams in real time, ideally, for dual languages. Say when there's a conversation happening between an agent and the customer. And when they are language agnostic, I would say, Hindi mixed with any of these Indic languages, we could do as such as 4 streams per core in real time. So that is one thing we did. Our problem does not stop there, but we need to infer what is being said. So the whole NLP layer comes into play, where how do you deduce what is being spoken? So there again, we work with the Intel team using the Intel NLP architect. We tried to optimize our inference engine. And the results that we got are pretty significant, especially when we are inferring data. So the 2 key achievements that we could do with Intel team or goals that we achieved is, one, optimizing the time for inference, and other one is again the time for inference in both the speech and the NLP layer. So this is the key learning that we got when we worked with the team with Intel.
Sure. Thank you.
Thank you.
Thanks, Ananth. So I'd like to leave you with one thought that I have in mind, and I believe this is where the juncture we are at, answering the question that I posed myself and to you at the start of the talk. I think we are at an unprecedented, junction where we have massive compute, we have massive data, and a chance to solve real-world problems that we've never solved before or have been dogging us for several years or eons, right? Now, what we can do with computing, or what computing can do with us, this is going to have a huge impact for the generations to come. That's how I look at the emergence of AI or the effect of AI on our lives. Thank you.